Good morning, all of you. My name is Annu from BSc Chemistry Honors second year. Today, my topic is distribution law. Non-nest distribution law definition. Non-nest distribution law studies the distribution of solute between two immiscible solvents in contact with each other. When a solute soluble in two immiscible solvent is added to a mixture of these solvents, the concentration of solute in both the solvent layers is different. In other words, the solute distributes itself in both the solvents. For example, when a dilute solution of iodine in water shaken with carbon tetrachloride, the iodine distributes between two immiscible solvents. Iodine is about 86 times more soluble in carbon tetrachloride than in water. Due to higher solubility, most of the iodine passes into CCl4. In simple words, iodine is distributed between two immiscible solvents, water and carbon tetrachloride. Nernst in 1891 showed that when a solute is added to a mixture of two immiscible liquids, in both of which it dissolves, then it distributes itself between both the liquids in such a way that the ratio of concentration of solute in both the liquid remains constant at constant temperature. However, the ratio is constant only when the solute has same molecular state in both the solvents. That is, solute neither undergoes association nor dissociation in both these solvents. The generalization put forward by Nernst is called Nernst distribution law and is stated as a solute distributes itself between two immiscible no solvents in contact with each other in such a way that at equilibrium the ratio of concentration of solute in the two layers is constant at given temperature, provided the molecular state of solute is same in the both solvents. If a solute X distributes itself between solvents A and B, the distribution law is written as concentration of X in solvent A upon concentration of X in solvent B is equal to C1 upon C2 is equal to K. The constant K is termed as partition coefficient or distribution coefficient. Factor affecting partition coefficient. First, nature of solute. Second, nature of liquid pair. Third, temperature. First, nature of solute. For a particular liquid, different solvent have different solubility. Hence, the value of partition coefficient